Hey everyone, welcome to the lecture for 9.3. So we're going to talk just briefly about the distributions that we're going to be using for our hypothesis test. So I want you to think back to when we were constructing confidence intervals. And we had two distributions that we used when we were using or constructing confidence intervals. We either chose to use a normal distribution or we chose to use a student's t-distribution. And so I want to kind of just revisit this little flow chart here. So we always started with our population and what did we want to know about it? What did we want to say about it? Well, we either wanted to talk about the mean, mu, so that's going to be going down the left side here, or we wanted to talk about the proportion, p, and that would be going down the right side. So let's start with proportion. If we wanted to know the population proportion, we would always use the normal distribution where we would get Z alpha and we would compute our standard error and all those things. But that all came from a normal sampling distribution. If we wanted to make a confidence interval about the mean, we had to first check whether or not we knew the population standard deviation. If we did know the population standard deviation, we would use the normal distribution and we would get a critical z-score or a z-value. If we didn't know the population standard deviation and we only had the sample standard deviation, we used the student's t-distribution where we had a critical t-score or t-value. And that's going to really align perfectly with what we're doing in hypothesis testing. So when we are going to do a hypothesis test based on some sample data, we're going to use a normal distribution unless we're testing for the mean when the standard deviation is unknown. In that case, we would use a student's t-distribution. We also have to check some assumptions about the population and the sample. So if we're going to perform a hypothesis test for a population mean, mu, and we're using a student's t-distribution, which sometimes we'll call a t-test, then our assumptions are as follows. Our data should be from a simple random sample. So remember that a simple random sample is where everyone in the population is equally likely to be chosen. Next, we need to know whether or not our population is approximately normally distributed. So the problem will either say that outright. Alternatively, if our sample size is sufficiently large, that is, if it's bigger than 30, then we can go ahead and use the t-test anyway. So it's approximately normal or our sample is 30 or larger. We have to meet one of those two. And the last thing, if we're going to do a t-test, is we have to use the sample standard deviation as an approximation to the population standard deviation. That is to say, make sure that we don't know our population standard deviation. And now we've met all of our assumptions for using a t-test. If, on the other hand, we're going to use a hypothesis test for a single population mean mu using a normal distribution or a z-test, we still need to have our simple random sample. We need to have that the population is approximately normal or that our sample size is 30 or larger. And in this case, we're going to use the population standard deviation as it's given to us. And in the last case, where we're doing a hypothesis test of a single population proportion, P, again, we're having a simple random sample from the population, but we have a little bit different requirements on the kind of second and third bullet points here. So we've got to meet the conditions for a binomial distribution, which is that we have a certain fixed number of trials n, which is typically our sample size as we saw when we constructed p hat. The outcomes of any trial are success or failure. Sometimes we think about that as a yes or no question. And then each trial has the same probability of success. And we're going to more or less kind of take that as granted when we do these problems. We also need that the shape of the binomial distribution needs to be similar to the shape of the normal distribution. And the way that we check this is we make sure that n times p and n times q are both greater than 5.